Hi. I am IT PhD and today we continue our adventures in C language. Today we will talk about variable types. It's a very important topic because even in one of our last past sessions we've met such interesting problem. So we wanted to check what's the maximum value for random number generation. So we printed something like this, print f, and we output maximum number which can be out of the run function. And what we had here, let's just compile, and we had such number. And I said to you, oh, I thought that it will be like 32,000 something, 32k, but it's appeared this value. And actually it's already we made quite dangerous, because for example, if I would try to output not the regular decimal but short decimal, in a second I'll tell you what does it mean. It means that we kind of take shorter number, we want to output shorter number, we will have really wrong output, you see. Yeah, so let's talk about what is short. We already talked about int type for variables. There are some other integer stuff, integer types of variables, for example short. So short, we have integer value which is has maximum value as a 2 billion. It could be up to 2 billion, and from like minus 2 billion till 2 billion. So we have also short, let's call it like number, and let's make it like 1000. It's also widely used. So to output integer we use just d, like this. So if we would try like output player gold, it will be simply like this, and it's 0, everything alright. If we want to output short, we add h to our specificator, and this way we output short. You see, by the way, I put this player gold to the short. It's alright to do like this. In this particular time I was lucky. So yeah, let's put our number. So this is short number. The thing is that short maximum value for the short number in our current specification will be 32,000 something, 32,000 something. You do not need to remember all these precise values, just approximately. So let's make it like 33,000, like this, and let's try to output 33,000. You see, we assigned to this value, to this to this variable, we assigned this number 33,000. But when we try to print it, we have something different. Even if we would do something like this, if we will try to output decimal, you see we still have a problem. Why? Because short. So if we will try to put something bigger, we would make overflow, and this could make your program horribly wrong. So it can just destroy everything, and like airplanes, they go down because of such stupid mistakes, or like spaceships too sometimes. So you should be super careful with this and use only appropriate size for variables. And how to know which size is bigger, which is smaller? Actually, it's not so easy. Let me just demonstrate you some funny things. So I'll just open other file which I have here. First, let's take a look at the maximum values which we could have for different types of variables. For example, what we have here. So I just took this from some website like CPP reference, this website called, I think. So basically char, it's a character type, yeah, like character A, B, C, D, you could put here. Int, it's integer, and like we have here short, long. There are not all stuff, not all stuff here, but some. So if we would compile, we will see maximum and minimum values for different types. And you could think, oh, it's all right, it's cool, so I just need to be careful, but not everything's so nice here, because these values, maximum values for different variable type, they depends from your compiler, they depends from your system. So for some systems they have like different types. So for example, there you could see there are some different data type systems, some old, which existed when Windows was like 16-bit IP. We would look at such values today. It's called LP model, like long pointer 32 bits and integer 16 bits. So what does it mean? It means that in this architecture, maximum integer value will be 32,000 something, not like 2 billion like we have in modern Windows. I use right now 64-bit Windows and modern compilers. That's why we have such values. So actually this is defined not by even operation system, but it's defined by compiler, because yeah, it's kind of complex thing. So let me demonstrate you small interesting thing. Let's leave this for now. So it's maximum values which I have with my current compiler. I could even, yeah, let's copy it. Let's copy it. So I'll copy it to WinMerge. It's beautiful. Try this program. It's very awesome program to compare stuff. So I'll copy it here, and then let me make compilation of the same code, but in another compiler. So we would run PowerShell bcc 32 main.c. Okay, compiled. Let's run it. And let's compare even, this is also not too old compiler. And if we would compare this value, even here we will see that there are some different values. Under Windows, it's the same operational system we have, but different compilers, they have kind of different values. But yeah, it's not a big deal. You would say that, okay, long, min, long, max. But if we would take a look at some very old stuff, for example, this is, in my past video I showed you this, it's Turbo C compiler, Turbo C++ compiler. So if we would try the same code which we have here, if we would run it, you would see that here maximum number for integer, int max, it's 32,767. So it's not 2 billion here, because it's 16-bit system. So, and I run it under, in DOSBox, it's virtual machine software, but still. So you should be, what I'm trying to say, that you should be super careful with this, because these values, they are different in our other systems. They are different within even one system under different compilers. So in our game, when we checked this random max value, we were quite close to making this mistake. So you see, if I tried decimal, but if for any case I would try like short, I would get wrong number. So it was on the edge. We almost kind of made a blunder. What to do in this case? How we could kind of avoid this stuff? So first of all, in most new programs, people use a library stdint. Actually, this library, it's very easy. It's not super special, but it just gives you possibility to use new types. So, for example, they introduce type like int 16t. It's basically this is the same as short. So if you would just use short integer, and like let's make number 2 and number 1, and let's assign to it, okay, like 200, and let's print it. Number 1 and number 2 first, and then second. So if we would print it, it's kind of will be the same. So if we would put here something like 40,000, we will have the same overflow. Yeah. So this library is give us possibility to use such values. But why do we need it? Okay, for short it's kind of the same. But for example, this value give you possibility to use something like this. Give you possibility to use custom type like 8 bits. So you could define certain amount of bits. Why it's important? Because as I showed you, different compilers, they have different types. So for example, some compilers, they have for the short int, some compilers has 32 bits. Some compilers has 16 bits. It depends on the compiler. So if you use such, so if you would use this library stdint, if you would use these special types, you will always know exact size of this variable, which is, as I showed you just now, super important. Let me explain in more detailed how to get these limits. Yeah, we saw this big file from CPP reference, but actually you could do it by yourself, like include a library header file limits.h, and if you include it, you will be able to see these constants. So if you would try printf %d, and you will put here like int max, you will see, okay, yeah, I need to delete this stuff. You will see that this is our maximum integer. Yeah, so if we would want to say minimum, make it minimum. Another interesting thing that actually, yeah, today we'll talk about data types, and now we know already int, we know short. The thing is that there is a way to make it signed or unsigned. By default, integer type is signed type. It means that it could be plus and minus. So as you see, when we make it integer min, it become it shows big negative number. So let's experiment a bit. So let's create integer value. Let's create it foo. Yeah, like that. So let's create integer value and say that it's minus 13, for example. And now we will just put it here. Foo. Yeah, you see it works. So it's because it's signed. So we could actually define it. We could say, because yeah, in most architectures, in most cases, it's like this, but in some compilers, some exotic ones, they could think that by default integer it's actually unsigned. And what means unsigned? Unsigned, it means that it can't be negative. So if we would try, if we would make it like this, if we define that it's unsigned integer, and we will try something like this, but it works because, yeah, if we would define here specifically in this specificator that we want to show unsigned decimal, then we will have such thing like something like this. So you see, we wanted to show 13, but it shows us something very strange. So yeah, actually you could even, if you would use just u, it will also u, it means unsigned. Yeah, let's make it like short, so it will be just easier for us to make some overflows around. So we make it for each data type could be unsigned or signed, even char. So if we would use char, by the way, yeah, it would be quite funny. So let's take it for later, and let's make char, and we would call it like bar, and assign to this char a. So let's print it like this, C, and we print bar. So we print bar. We have a here. It's all right, as it should be. Yeah, but let's make it a bit different. Let's show not character, but actually decimal. It will be funny. Because as I said in some of my previous videos, yeah, it's always nice to repeat such stuff, that all characters in C language, they're basically stored as certain numbers. For example, A stored as 65, capital B stored 66, and etc. So we could always output our characters like numbers. So let's make it, let's first check. Let's check what's the maximum character which we could have. So we make, let's just clone this line. A bit messy we have here, but it's all right. Let's check constant. I am not sure which one. I think it's like char max, I think. So let's try. Okay, you see. So by default, we know that in ASCII table we have actually 255 different characters. Yeah, because it's 8-bit. So 8-bit. It's actually not even up to 8-bit. It's always 8-bit. But sometimes this 8-bit, what does it mean 8-bit? It's basically 8 zeros or 8 8 zeros or 8 ones. So it's how everything stored in the PC. So this, for example, this is number 1, this is number 3, this is number 2. So I'll make a video about this stuff later on. But what's the most important thing, that combinations, maximum amount of combinations here, it's actually when we put all stuff as ones, and it will be 1 second, let's close it for now, and it will be 255. So it will be this, the last character, 255, empty space and BSP. So okay, they're not empty but like space. So here it's like this. The thing is that, by the way, if we would add here, if we would go to binary, let's learn about binary some stuff. If we would make the same thing, so it's 255. Yeah, let's just 1 second to get distracted a bit and to rest. So if we would make it like this, if we move it 1 and add 1 more 0, it will be already 256. Yeah, so it will be 257 and etc. So it's how binary system works, in just a few words about it for now. Later on we will make a detailed video. So here, as we know that maximum it's 255, but if we would look at character max, we see 127. Why it's so? Yeah, because by default character, it's also this type, it's always signed. So actually char bar it's the same as signed char bar. So that's why it could be from minus 28 to minus to 127. So let's check mine. Minimum 28, you see. By the way, let me, yeah. One second, I'll run my add-on. Okay. So, and maximum, let's remember it again. We have 127. It's because 1 is taken for the sign. We will talk about a bit later, but for now you could just already get used to it. It's a good thing. So but we can make it unsigned. Actually, we could make it unsigned, and then if we would put it, yeah, let's, as you know, we could output numbers, but also we could use we could also use actually these numbers here. So we could do not use symbols, but we could use, like, for example, and if we would try to print this number here, let's try as a character this time. What we will have? We have E, because 69 it's E in ASCII table. Yeah, so if we would open it, we would see that 69 it's E. Awesome. So yeah, but if we would make it like unsigned and would try the same thing, it actually wouldn't make everything bad. Yeah, but if we would make it unsigned and we make it like this, it's also be all right. Oh yeah, it should be character here. Sorry. Yeah. You see, it will be it will just print another digit. If we would make it negative though, if we would try to make it negative 69, 79, okay, it will also print something to us, but it's actually like overflow, because if we would try to use decimal, we would see that, okay, we wanted to print minus 79, but we print here 177. So it's a really critical thing to remember about this, about signed, unsigned, and always better to actually make it like properly define your variables, properly declare them. Yeah. So again, declaring variable, it's when you just write like character action, it's you declare variable. But if you say that character action 1, it's a, this value, you assign value a to the variable action, it's defining. This is declaring, this is defining. I myself, as I'm not an English speaker native, I sometimes make mistakes in this, so I'm sorry in advance. But yeah, we should remember these two definitions. So what else we have? So we already know about character, we know about integer, we know about signed and unsigned. Also there is a long variable. Long, it's kind of right now in most of the architectures like Windows, okay, it's the same as an integer. So long also has 2 billion maximum value for long, it's 2 billion. The thing is, by the way, that even integer value, let's create integer value and make it like 4 billion, not 2 but 4. The thing is that if, as I said, maximum integer value it's 2 billion, but we will use 4. But if it will be unsigned, it will be all right, because unsigned integer, its maximum value it's 4 billions. So let's print it. like this. Yeah, you see, we need to specify that it's unsigned. So we need to write it here, u. Yeah. You see, now it works because we write it u. Yeah, no need this d here. So to output unsigned. So if it will be signed, it will be overflow. Not in this particular case, but yeah, in this. What else? We also have, so yeah, unsigned, signed integer, it's the same thing as long, but in different, some architecture and some systems and compilers, it could be different things, long and int. But there is also long integer. Maximum for long, it's kind of a very huge number, like be very huge. So even if we would add something like this here, I think we will be able to print it. So to print it, we use ll. To print long value, we use ll. You see, it works. Next value, it's floating point type. So we use float keyword to define this type, and then let's make it like value. So with this, we can make some floating point numbers, and we could print them. To print floating point numbers, we use f specifier in our printf. So like this. The thing is that if we try to output float number as a decimal, we would have a problem. And if we try like this, for example, if we want the half, it's not rounding anywhere. It's just wrong, because in the memory, these zeros and ones, they have different way to store it. It's like I said about negative number. For example, this is 1. This is 1. Okay, let's make it. This is 2. 2 in binary system. But this will be, if I'll add 1 in the beginning, it will be -2. No, something like this. There is actually a more complex system to change it. But I mean, 1 bit in the beginning, it's sign bit. And when you store your floating point values, they stored in special way. So that's why you can't just output them like this. You can't process them like this. So to use, you should use this f. So now let's take a look what's the maximum value for floating numbers. To do so, we need to include library which called float.h, and we use float max constant here, and let's output it as a float like this. Bam! You see, it's really huge number. The thing is that floating numbers, they have their own like precision. So they could store a lot of different stuff, but like by different precision. By the way, there is a nice specificator for printf, which called g, which show us a scientific notation. So here, this number, it's kind of human readable, because previously we saw just huge number and it's hard to understand. And here we see that it's okay. It's plus 38. So it's in 3 in 38th grade, something like this. So E plus 38, scientific notation. And also we could see like float minimum here. Yeah. And yeah, till minus 38. So it's really big one. Another type which we could look at, it's not float but double. So yeah, float, it's this number we saw. So let's take a look at double. Double, it's basically the same float, but it's has double precision. So that's why it's called double. So it's like float twice. So if we try to print this now, like this. Yeah, but actually we use like LF. So to to show double, we use LF, like long float. Yeah, now we see it. And maximum number for long, for double, it's double max. So let's take a look. Yeah, it's huge number, just impossible to even imagine this. But let's use G notation like this. And we see it's just 308. So we went through main types. Also there are some other types like bool, which is in library include stdbool.h. So this type we use it mainly for flags on off, for example. So by default we have it 0, and then we can change it somewhere in the code and then print. So like this. If we try to print it, it will be 0. But if we would like make it +1, it will be 1. But if we would make it +2, okay, it will be 2 because we digital, but yeah, let's make it like this. Let's make it 2. Yeah, you see, even though we made it 2, it's still 1, because bool could have only 2 values, 0 or 1. Yeah, so also there are some additional data types like structures, but we will talk about structures later on in our game. So when we would continue to write our game, we'll talk about structures, and we would also talk about pointers. But we talked, by the way, about arrays. Already we know some stuff about arrays, but we will talk about them when we will talk about pointers and about unions also. So thank you very much for watching. It was IT PhD. Don't forget to subscribe to my channel. Hope to see your comments. Bye bye.